Okay. Alright, so for JKE 316E Quantitative Economics, so, okay, thank you. I see PH Tan Sian Siong, okay, online. Thank you very much. Okay, so what we'll do today is actually discuss topics from Kerala Chapter 10 on interval estimation. In order for us to do that, we need to discuss a little bit of sampling distributions from Chapter 9. Okay, and I think I need to go through and explain about OER, Open Educational Resources at USM. Okay, where from ocw.usm.my, I think I already saw BH Tan and Sen Siong already part of this. Okay, thank you very much. Okay, so the questions now is, since there are a lot of materials being available, okay, especially for quantitative economics here. Okay, so if you look at the content, you have the whole syllabus. Okay, I would suggest that you go and read the explanation. For example, this one, you understand that this is a third year course, okay, and so on. Okay, let's look at the course objective. Okay, the course objective, let me make it bigger. Okay, control plus, okay, you can have increase the size, okay, control minus, okay, that is the simple trick. So the overall course objective, okay, so we have done this in the first WebEx session. Okay, you must be able to differentiate between descriptive statistic. Okay, remember when you describe statistic in terms of the averages, mean, median, and mode, in terms of you describe, okay, sample statistic in terms of the variance, okay, in terms of, the variation in terms of range, okay, quartile, okay, standard deviation, variance, and then you describe in terms of skewedness, okay, whether it's skewed to the right, whether it's skewed to the left. Okay, what we want is normal distributions. That is the main assumption. Okay, so later on, okay, especially from the last part where we discuss normal distributions, okay, and today we are going to discuss interval estimation. So this is the second part where what we are doing is called as inferential statistic ataupun statistik penaakulan. So it's like we are going to, from sample value, you're going to explain about population value. You're going to estimate. You're going to make forecast. You're going to do hypothesis testing. So all of that is what we call as inferential statistic. Okay, so other than differentiating between descriptive and inferential statistic, you must be able to apply statistical analysis technique in solving economic problems. Okay, exam question will be given in terms of scenario. For example, you'll be input in the position of manager or something, or as deans of a school, as policymakers, as the governments. Okay, so you have to solve the problem using the statistical technique. For example, okay, later on we'll look at this part where how do we apply this mean, median, and mode in real life. Okay, what does it, the discussion. Why we have these three different measures of averages. Okay, eventually when it comes to chapter on regressions, okay, you must be able to develop models, okay, and analyze economic variable. This one is based on economic theory. The simple economic theory that you have done or you have known from before, which is production function. Remember that? Tan Sian Siong, based on what is the basic production function? Can you recall? Okay, direct now. Okay, Q as a function of K and L. That means output berfungsi kepada input capital, okay, dan juga input buruh. So you can write that Q, okay, equals to function of the x1, which is K, and x2, which is L. Okay. From there, you can analyze economic issues and problems through quantitative perspective. Okay, so if you look at the linear outcome, I already explained this last time in the first session. You must know about the subject. Okay, so in this case, when we discuss chapter 4, okay, what is averages? And today we are going to discuss chapter 10, okay, estimation. You must know what is estimation is all about. Okay, so that will give you the motivation to study the chapter. And in the second part of the course, okay, when you study chapter 10, for example, you must have the skill usage of respective formula. You must know, okay, chapter 10, this is the formula, okay, this is how you calculate them, okay, this for exam, okay, that means manual calculations. Okay, but then in part C, you must be able to use the same formula, but this time for huge group of data, so you're going to analyze using software. Okay, so Excel add-on is the one available from Keller, but for at work, you must have something like SPSS, R, okay, and then all the other things, Tata, and so on and so forth. And last but not least, the interpretation of the statistic. When you calculate means, you must be able to explain what is the meaning of this figure. What is the significance of having hypothesis test? What is the meaning of this interval estimation? Okay, so that is what you need to have in your hands at the end of each topic. You must know what it's all about, how to calculate, okay, using formula for written exam, how to use the software, okay, for huge data, and how to interpret the values. So if you look at this part 1, for each part of the content in Open Courseware USM, so basically, you do not need to read the whole chapter. So if you're a smart student, okay, I saw Anip online now, okay, I'm not saying that Anip is smart based on not, so because I just saw Anip, okay, so everyone is smart student. So you must know this, okay, from chapter 1. What do you need to know? Okay, so basically chapter 1 is just introduction. You must to know, you must be able to differentiate the different key concepts of statistics, population versus sample, parameter versus statistic. So that's it. Don't crack your head, okay, trying to, translate every word, as long as you know, okay, population is important, sample is important, parameter, statistic important, inferences, disparity is important, and that is sufficient. Okay, I know that you are busy people. So when you sit down to study, you must focus. So this learning objective or learning outcome tells you what you need to focus on. Okay, from chapter 2, when we talk about graph and tabular. Tabular from the word table. So it's not like something new there. Tabular means anything in table form. So we call that tabular descriptive techniques. So yeah, what is the two important graph and table? Okay, basically graph, we are talking about histogram and ogive. In order for you to calculate histogram and ogive, you need to have this table of cumulative frequency. How you calculate cumulative frequency? And how come we there is a difference between carta bar ataupun kita panggil bar chart with histogram. So this is where it comes from, because the different type of data. Because discrete versus continuous, nominal versus interval. When we are talking about different number of students in terms of male and female, Malay, Chinese, Indian, so that one you will use bar chart because that one is not interval data. Okay, but if we are talking about income under certain group, so that is interval data, then you can use histogram and ogive. Similarly for chapter 4, okay, you must be able to describe data using measure of central location and averages, the mean, median, and mode, measure of variability, standard deviation, variance, range, interquartile. So if you look at this part, it looks like, wow, I have so many formula to memorize. You have formula for mean, formula for median, formula for mode, standard deviation, variance, okay, there are so many formula. But, okay, if you know standard deviation, okay, then you can simply S square, okay, because square root, okay, will give you the variance. Okay, if you know range, and then you can calculate interquartile range. What is this new word, interquartile range? Is it something that is new to you? No, when we talk from the word quarter. So interquartile range, we are talking about quarter 1, okay, and quarter 3. So that is the range. Okay, and then we have measure of steepness, coefficient of variation from the word variation. So it must be related to standard deviation and variance. So if you know one formula, that will help you to understand or to remember the next formula. So don't count, there are many different formulas. It's just that If you know one, automatically you remember the others. Okay, so learning objective, you must pay attention to that. Okay, and then you need to look at the videos. Okay, and I already highlight the videos are quite long. Okay, but you can stop anytime, you can replay, okay, you can repeat, okay, whatsoever. Okay, so again, the video is very focused, the details of each chapter. Okay, so you must go through the videos at least, a couple of times, okay, in order for you to understand the course. Okay, and then you have the slides. Okay, so for example, this is the slide, the detailed slide. What I discussed during WebEx is just the overview. So I'm going to do that as well with interval estimation today, the overview of interval estimation. For the detail of interval estimation, then you need to go to the OpenCourseWare, okay, as well as the slide that is available at available at e-learning portals. Okay, so you have the slides, and then you have the additional learning content. So if you're smart, okay, so this is where, okay, you don't understand certain things, okay, you can go Google yourself. Okay, you already know the keyword. What are the important keywords for each topic or for each chapter? Then you can go and Google. That will give you the specific resources. You can .pdf, okay, colon, okay, and then, for example, data description. So all about data description. Or you can use this blank space, YouTube video, okay, that I already upload, slide share, as well as some motivations here. And then you can do the quiz. Okay, this quiz is not part of your assessment, okay, but this is to test your understanding of key concepts. And it will be good if you are able to answer this, because for PB, I'll give multiple choice questions to help students. If I give all calculation students, then all my students will not score. So I did have about 20 MCQ that will contribute 20 times 2 marks, so 40%. And then you will have to answer 3 sets of calculation questions within all of that within 1.5 hours. So you answer these quiz questions, right? Okay. For PB, you will have the English as well as the Malay translation. So you have the quiz, you can answer this. And then what is interesting is, especially if you are working, okay, and your line of work, even if you are if you are doing business, or even if you are just reading the newspaper, you will come across articles using, for example, the median wage, okay, median annual salary, okay. Why median? Okay, when we discuss wage, why shouldn't they calculate average wage in terms of arithmetic means? Why they do not use mode for wage? Okay, you have to think, because that will go back to the advantage and disadvantage of using the different mean, median, and mode. Okay, similarly, when we talk about this another article, okay, when we talk about average length of pregnancy, okay, and then you have this information varied as much as 37 days, almost 1 month, more than 1 month. Okay, so have you ever wondered why is that? Okay, just now we have the different part of averages. Why do we need to know about variance? Okay, so this is why. Okay, because we are not sure. Not everyone will give birth at the same time. Okay, for example, at the end of 38 weeks. Okay, there might be those who give birth early, or those who give birth 2 weeks late. Okay, so that is the variation. So if you are working in production line, okay, for example, mineral water bottle, so you will see this variation. It's very important, especially if you are trying to hold on to standard, your ISO standard. So you cannot be putting a label, 500 liter, but then your product is very much less than 500 ml. Okay, so it has to be close to 500 ml. There's another article. It caused quite an uproar when at the Prime Minister Department, Datuk Seri Abdul Wahid Omar, said that average household income was, at that time, 2012, 5,000 ringgit a month. So, and then there are quite a significant number of us. Okay, in our family, you can look around and say, no, this is not true. Okay, not everyone is having this 500 ringgit a month. Okay, might be one or two. Okay, the people that you know. So that means, how do you calculate this? What does it represent? Is it wrong? Is it right? So as a student who learns statistics in quantitative economics, and you already know about macroeconomics, what is this per capita GDP? What does it mean? Okay, we are using that for a comparison over time. We are using that for cross-country comparison. So it's not for comparison between your salary and the average household salary. Obviously, it's different. Okay, and then you have the assignment. So there are some variation. So for this academic year, I'm more interested in the odd number questions. For the even number questions, okay, assignment 2 will came out after today, okay, stand by Monday, which will combine questions from normal distribution as well as interval estimation. So I'm interested in the odd number question, because the even number questions, you have the answer at the end of the book, so you can do and, mark yourself. Okay, so and then just this one line, okay, it tells you what you should know at the end of each part or each chapter. Okay, so this is how you use this open courseware USM. So you need to register for the first time, and then you can log in. So for today, okay, I'm not going to upload the slide. You already have this learning objective online. Okay, the slide from normal distributions. Okay, so today we'll go into sampling, distribution, and estimation. Okay, you can go here. Okay. Okay, so, alright. So this is about chapter 9, sampling, distribution. I'll skip this and let's go to our preview. Oh, okay, it's already here. Okay. Okay, I think I need to lower the volume as usual. Okay. Okay, sorry. Alright, so very good. Okay, let's start with our topic for today. Okay, we'll start with chapter 9. Chapter 9 will be for to provide the understanding how can we use interval estimations. So this understanding is very important because it will explain why, okay, we have to take sample. Okay, we already done that. Okay, so in this case, how do we get that bell-shaped curve from last WebEx session, that normal distribution, it has to be bell-shaped, the mean, okay, has to be in the middle here. So this is also the mode, so this is also the median. So if you have that characteristic, it's not skewed to the right, it's not skewed to the left, so this is bell-shaped, this is normal distributions. Okay, so when we talk about normal distribution, so we have the sampling distribution of sample mean. So what does it mean? It's simply that the probability distribution of all possible value of random variable x bar that you compute for a sample of size n, okay, from a population with a mean mu and standard deviation sigma. Okay, so we have Shidi online now. Okay, hello Shidi. So that will give you this bell-shaped distribution. Okay, so remember, this is our most important assumption, and we need to assume this because we are taking quite a number of samples. Okay, remember you have a huge population, so the true population value or population parameter is we use the symbol mu and then the symbol sigma. Okay, if you take sample one time, so let's call that sample 1, that will give you x bar 1. That means you calculate the mean for sample 1. And then you do the same thing for the second sample. You calculate the mean, that will give you x bar 2. Okay, and then for sample 3, you get x bar 3, x bar 4, and x bar 5. So x bar 1, 2, 3, 4, 5, this is the sample statistic. For each sample as well, you also calculate the sample standard deviation. S1 here, S2, S3, S4, and S5. Okay, and it's very important for you to note that even though we depend on sampling distribution model, we never actually get to see them. So you need to imagine, to have this imaginary bell-shaped curve in your mind. Okay, so because we never actually take repeated sample from the same population and make histogram, we just imagine and simulate them. Okay, but I already asked you to draw histogram, to do sampling from the first and the second WebEx session. So now you have idea how come eventually we use this bell-shaped curve. Okay, any questions so far? Okay, so next part, okay, from that sampling distributions, we have the central limit theorem. This one is not clear, but I have something clearer. Okay, this is the part. Okay. Oh, sorry. Okay, so wait. All right. So in this part, okay, when we talk about, let's say you have, this is one example to illustrate sampling distribution, how you get the bell-shaped curve. So imagine you have this population. There are 3 items. You have number 2, you have number 3, you have number 4. So your population sample size, capital N, is 3. So you are asked to take a sample of 2 items. So your small n, sample statistic n, 2. So if you calculate the population mean, okay, mu, so 2 plus 3 plus 4, that will give you what? 2 plus 3 plus 4, that will give you 9. 9 divided by 3 items. So mean or arithmetic means average for this population is 3, correct? And if you calculate the population variance, sigma square, okay, for this variable, okay, then you will get 0.66. Okay, but if you take sample of 2, okay, for example, lelak mata randomly antara 2, 3, 4, okay, you choose 2 and 3. Okay, 2 and 3, what is the mean? 2 plus 3, okay, 5. 5 divided by 2. Why not divide by 3? I think you already understand that. Okay, 2 plus 3, 5 divided by 2, that will give you 2.5. 2 twice. Okay, 2.5 twice. So this is it. The original data is 2, this block, and then 3, this block, and then 4, this block. But when you take the first sample, okay, 2 numbers, okay, you take 2 and 3, that will give you 2.5, okay, average. Okay, and then let's say you take another sample of 2 items. This time, randomly, you pick 3 and 4. 3 plus 4, 7 divided by 2, so you get this 3.5. Okay, so you have this, so you build this, so it looks like your histogram. And if you connect the middle point of each histogram, so that will give you roughly the bell-shaped curve. Okay, so we start with a rectangular population. 2, 3, and 4 is the original block. 2, 3, and 4. Okay, and then you take sample of 2. Then you get the first sample mu 2.5. Second sample mu x bar 3.5. So, and you represent them on this histogram. If you connect, you will have your bell-shaped curve. And your sigma now becomes 0.33. Okay, this is the illustration. In exam, I'm not going to ask you to do this. Okay. All right. And then we have, from that sampling distribution, the theory. Okay, that means this is something that you need to hold on to. This is something that you cannot argue anymore. Okay, you simply have to accept this theorem. Okay, it's fixed. Okay, so the first central limit theorem said, if the population distribution is Gaussian, the sampling distribution will be Gaussian. Mana pula data ni Gaussian ni? Okay, is it something new? No, Gaussian is basically another way, another word to explain normal distribution. Okay, so this sentence is saying, if the population distribution is normally distributed, then the sampling distribution will also be normally distributed. Okay, that is to be expected. But the second sentence, even if the population distribution is not normal, that means when we talk about population of Malaysia, okay, in terms of income, okay, the distribution is not normal. Mungkin ada cenderung skewed to the right. Maksudnya yang gaji million tu adalah, okay, sedangkan yang bottom billion tu gaji, RM900. So it's skewed to the right. Okay, but if you keep on taking sample, population of Malaysia. Okay, this is just to illustrate the meaning of this sentence. So you will have the sampling distribution to be approximately. Maksudnya dia menghampiri normal distribution if the sample size is large enough. So when we use normal distribution, the sample has to be more than 30. So sample size is small n, so n has to be more than 30. If your n is less than 30 or less than 30, then you need to use the student T distributions. Okay, you can read on that. Okay, in the text. Okay, if student T distribution, then you need to use the student T table. Okay, T table, not normal distributions table. You can have a look at this. Details in this slide. Okay. That is the first theorem, and then we have the central limit theorem. So, because we are taking sample from the true populations, so what you get is statistic, for example, X bar. So, the mean of the sample mean, okay, the expected value of mu will be your mu, okay. The mean of the sample mean will be your population mean, okay. This one you have to remember. Okay, and then the standard deviation of the sampling distribution. This is something that is new. Okay, you have to remember from now and onwards. Okay, the standard deviation of the sampling distribution is what we call as standard error. Sebelum ni dah belajar standard deviations. Now I'm going to introduce to you what is this standard error. So this standard error is related to the population standard deviation by this formula. So standard error SE is equals to your standard deviation, population standard deviation sigma. Okay, sample standard deviation we use small s. You need to divide this with the square root of the sample size. Okay, so that is standard error. You will see a lot of this. Okay, standard error today. Alright. So we are done with chapter 9. What is sampling distribution is all about. What you need to know is simply the central limit theorem. Okay, the assumption of normal distributions or Gaussian. Okay, the name Gauss to maksud referring to normal distribution is very important. So the next part that you need to know is chapter 10, interval estimation. Okay, let's look at this estimation. Okay, what is estimation? Siapa nak explain? Shidi, Anip, Bishtan, ke Siong-Siong? Tak ada nak explain? Tak ada soalan? Okay, I keep on asking questions. So I hope when you study, you will use this study technique as well. Okay, you know, ask yourself, at the end of this, I need to know what is estimation. So I'll explain. Okay, dah ada dah. Okay, estimation is ramalan. Ramalan tu dia lebih pada macam, apa ni? Orang yang tengok, bukan mereka, orang yang tengok that Sagittarius or that, itu ramalan. Tapi betul lah, to a certain extent is correct. So, estimation is what we call anggaran. Anggaran ni dia lebih scientific. Ramalan ni dia lebih macam banyak hanky-panky sikit. You just ramal, you know, how you predict, how you ramal. Okay, we estimate. And then we can say with a certain degree of certainty that our estimation is correct. So that is estimation. Thank you for trying to answer. It's correct but not exact answer. Okay, so what is estimation ataupun penganggaran selang? Okay, selang menunjuk ke interval. So in this case, the same concept. Okay, when we talk about statistics, you are taking from population, okay, a sample. Okay, population value, okay, for example, okay, we calculate mean is always unknown. But from sample, you take sample mean X bar, so you get a value. So now, is it correct or is it fair to say from one small sample, X bar equals to a value, and you say that X bar is mu? Okay, so if you say, from this X bar mu, X bar equals to 50, you say that mu is estimated to be 50, you are making a point estimation. Maksudnya anda buat anggaran titik. Okay, bila buat anggaran titik, what if you, the actual mean is actually 51.5. That means you punya anggaran dah salah. What if your population mean is actually 48.9? Okay, that means your point estimate is wrong. So because of that, okay, we know that, we are taking a sample, okay, and you already learned about sampling error from last time. It's possible that you do your best, okay, to pick the sample, but still there are error in your sampling process. So we need to make room, okay, allow room for that error. So you're not going to say point estimation, you're going to go for interval estimation. So instead of saying S bar equals to 50 as mean, you're going to say that I'm 95% confident that the mean of the population will stand between 40 and 60. Okay, so that will give you that room. Okay, 50 is in the middle. So plus 10, that upper limit, that will give you 60. Minus 10, okay, that will give you the lower limit of 40. So it's more correct. So, there is some room for you to haggle that. So that limit, upper limit and lower limit with the mean, okay, sample mean in between. So this is what we call as interval estimation. You have this margin of error, okay. So estimation is still to a certain extent, to a certain degree, 95% confident. It's still it has to fall within this range, okay. So try to imagine that this is what interval estimation is all about. Okay, and from normal distribution from last WebEx session, you already know what is the probability, the whole area under the curve yang shaded in blue ni. Okay, so what's the probability it fall between plus minus 2? That means given that mean, the standard Z, mean is always 0. So plus 2 and minus 2, what's the probability here? Okay, so the probability will be, it's not exactly 2, it's actually 1.96 positive. So that is before 2. And this is 1.96 negative. So this is 95% confident. And if we are talking about plus 3 and minus 3, we are talking about 99% confident. In statistics with me, okay, for JKE 316E, most of the time we are going to use either 95% confident interval or 99% confident interval. We seldomly use 90% confident interval, but you can try that, okay? But we normally go for 95% and 99%. Okay, so you have to remember this. For standard normal distribution with mean of 0, so 95% of area in blue, this is the probability 95%. So that's why we say 95% confidence. Okay, if we are talking about plus minus 3, okay, so the area extend to the right up to 3 and then up to minus 3 here, that will give you 99% confidence interval. Okay, so this is what I meant just now. That means, it's a very broad area, room for error. Okay, that means we are talking about 99.7% of data are within this range. This is the upper limit, this is the lower limit. So given that mu is here, so it's always mu plus something or mu minus something. So similarly, if you are using the 95% confident interval, you are 95% confident, so it has to be plus 1.96. Kita bulatkan jadi 2, but in exam, try to retain 2 to 4 decimal places. Jangan bulatkan lagi. Okay, and then minus to 1.96. If we are talking about 68% probability here of confidence, this will give you plus 1 and minus 1, 0.5. Okay, so it's 1 standard deviation away from the mean. Okay, so remember this. You need to keep on imagining this thing. So now this is the formula. So this is the sample statistic. Okay, so today I'm going to concentrate on X bar. Later on, okay, you can replace this with population proportion. So the concept remains the same. Okay, sample statistic. What you want to estimate is population value. So how you estimate population value? You take the sample value, you plus minus with this part. What is this part? The right hand side. This is what we call as the standard error. The one that I introduced it earlier in chapter 9. The right hand side of the formula is known as standard error. So you have the Z value, okay, from the confidence interval, you read the table. Okay, I always suggest for students, okay, just memorize this Z value for a certain confidence level. It's much easier that way. Jangan in exam baru nak JKE nak buka tables. Memorize lagi cepat. Okay, and then this is the S. What is S? Sample standard deviation. Divide by square root of N. What is N? This is the sample size. Okay, this is the only formula, the basic formula. Okay, and then we have this, the next one. Okay, this is the standard deviation in detail. So this is standard deviation. Okay, this is the population symbol, or you can replace this with the sample standard deviations as. This is the sample size, small n. Okay, you take the square root. Okay, and then from the confidence level just now, it's either 99% or 95% confidence level. So that is your alpha. Alpha stood for confidence level. You need to divide by 2. Why do we need to divide by 2 again? Okay, then you need to go back to this bell-shaped curve because we are talking about plus and minus. So that means half on the right-hand side, half on the left-hand side at any one point of time. So that's why we need to divide by 2. So when we talk about 99% confidence interval, okay, 99%, so the confidence level 2, you need to divide by 2. And you need to know what is the Z value for that area. Okay, divide by 2. Okay, so you just know this formula. Okay, and this is the details. Okay, so these two come from that plus minus 1.96 just now. I don't want you to use 2. Okay, I want you to use 1.96. So that is more exact, that is more correct. Okay, this is the explanation. Okay, so this is again, okay, since I already showed you just now. Okay, when we talk about location of the true value, do not use point estimate. Okay, typo here because this is not my slide. This is a slide that I taken online. So point estimate and confidence interval estimation will give you something else. Point estimate will give you 70.3 kg. Okay, so we are talking about average value. Okay, you estimate. Okay, this is it, 70.3 kg. Okay, so this is point estimation. But if you use interval estimation with a certain level of confidence, so you always say at 95% confidence level, okay, you estimate mu equals to X bar plus minus 5.75. That means 70.3 plus minus 5.75. So that will give you the selang penganggaran. Yang plus tu will give you the upper limit. And when you minus 70.3 minus 5.75, that will give you the lower limit. Okay? So quite simple actually. So we are done. Okay, so I'm going to go back to the slide just now. Sorry, the open courseware. Where is the open courseware? Okay. So when we talk about the open courseware estimation, so I did discuss. Okay, this one. This is the slide just now. Okay, to explain the difference between point estimate and then interval estimate. Okay, the details. Okay, you see the examples. Okay, point and interval estimations. Okay, the questions. Okay, the scenario will give you a hint. Okay, you must look for this information. What is the sample size? Okay, in this sample size, where we want to estimate the mean summer income of a class of business student. So the sample size is 25 students. So X bar is calculated to be $400 per week. So this is the sample statistic, point estimate. So for interval estimate, so you need to have a statement something like this, interpret. the mean income is between, okay, X bar, okay, between 380 and 420. The sample mean is always in the middle, because this is the lower limit, minus 20, you get 380, plus 20, okay, we give you the upper limit, 420. Okay, this is what I want to discuss now. Okay, this is the just now from the central limit theorem, okay, and then you already have the formula, you do the calculation. Okay, when you do this, okay, you must understand this is the quality of estimator that we want. It has to be an unbiased. Dia tak boleh pincang, dia tak boleh berat sebelah. Okay, so when we estimate value of mean using X bar, it has to be unbiased. So an unbiased estimator of a population parameter is an estimator whose expected value is equal to that parameter. So in mathematical form, you will write as E in bracket mu, okay, close bracket, is equals to mu. That means E is referring to expected value of mean is equals to that mean. So it's true. Okay, it's unbiased. Okay, and the second quality of estimator is it has to be consistent. That means an unbiased estimator is said to be consistent if the difference between the estimator and the parameter grows smaller as the sample size grows larger. You will understand this once you do the assignment, where we'll play along, okay, not using that formula only. We're going to play along, change one item in that formula, okay, one at a time. So you'll see what are the changes. Okay, and the third desirable quality of estimator is that if you have two unbiased estimator of a parameter, the one whose variance is smaller is said to be relatively efficient. We want the variance to be small. That means the area to be lagi padat lah. So that means lagi kecil dia punya tu lagi rendah the margin of error. Okay? So this is what I meant just now. Oh, it's here. So expected value of X is equals to mu. Consistent. We write this as sigma divided by n just now. Okay, so that will give you the standard error formula. We use S, okay, divided by square root of n. Because it comes from this formula. Variance is S squared divided by n. Relative efficiency. Okay, so this is the formula from before. Okay, and I'm going to show you one example. So this is how you write in the exam. So sample value X bar plus minus, usually you write one time. So plus minus ni you tindihkan lah. Okay, and then the Z values using whether 95% or 99% confidence level. Okay, and then this part of the standard error, variance, okay, sigma divided by square root of n. Okay, so you have this example now. You are given a scenario. This is the typical exam questions. The scenario can be anything from manufacturing sector, from government, from schools, university. Okay, you'll be given a scenario. Okay, so in this case, a door computer company, blah, 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 blah. Okay, they make each of its 5 most popular computer, blah, 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 blah. Okay, the operation manager wants to lower the cost. Okay, and this is the highlight. He notes that demand during lead time is normally distributed. So this is the assumptions now. If it's not normally distributed, you cannot use this formula. Because our calculation is based totally on the assumption of central limit theorem, Gaussian, okay, normally distributed. So in this case, he needs to know the mean to compute the optimal inventory level. So he observed 25 lead time period. So he does, you know, the questions are not say small n is 25. You need to understand. Oh, sebab dia perhatikan, okay, tempoh sebanyak 25. So this is your n, small n. And then you will have this word, 95% confidence interval. That means you need to use 95, not 99. Okay, and then you also be given the value of standard deviation. Okay, blah, 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 blah. So this is the formula. Replace the value into the formula. Okay, so X bar is 370.16. Okay, this is the original formula. In exam, I want you to write this. Okay, you can skip and give me the final answer. Okay, Bihishtan did ask me. Okay, yes, I'm looking for final answer. If you get exactly 370.16 plus minus 29.40, I will give you marks. But let's say it's wrong, this part, or it's wrong in terms of the sample, then I need to go back and check. Do you have the correct formula? Do you replace X bar with the correct value? Do you replace this 95% confidence interval? The Z value should be 1.96. Okay, do you have the correct sigma 75? Do you have the correct sample size? Be careful. The rule of the mathematics is that you need to solve the square root, you need to divide this, and then you need to multiply with 1.96. Kalau you salah kira, okay, you will not get this 29.4. You might get some other figure. So the rule of mathematics, darab dengan bahagi kena buat dulu, yang dalam bracket kena buat dulu, lepas tu baru campur tolak. Okay, jangan 370.16 plus 1.96 answer then multiply. Okay, you won't get this answer. Okay, and this is not yet the full marks. Okay, kalau you jawab yang ni, belum dapat markah penuh. Why? Because I need you to explain. What is this? Okay, nak kena campur tu dapat apa? Nak kalau ditolak ni dapat apa? Okay, this is the computer methods. Okay, you need to do that as well. That will give you this output. Okay, blah, 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 blah. Okay, so when it comes to the interpretations, okay, so tadi jawapan ni tadi, 370 plus 29, lebih kurang 370 plus 30 lah, dia jadi 400. 370 minus 30, roughly we are talking about 340. Okay, so roughly, you try to maintain 2 to 4 decimal places. Jangan lebih daripada 4 decimal places untuk final answer and working. Jangan kurang daripada 2 decimal places untuk answer and also your working. So this is the answer just now. So the estimation for the mean demand during lead time adalah di antara 340.76 dan 399.56. Okay, so you can use this figure estimation, interval estimation. But, okay, what we mean is that this type of estimation is correct 95% of the time. There's also possibility, walaupun dia jatuh kat sini, okay, there's also possibility you akan salah. Okay, the estimator will be incorrect. Okay, cara yang ni, okay, the media often refer to 95% figure as 19 out of 20, which emphasize the long run aspect. Dari segi probability lah. Kalau you ambil 20 kali, okay, gunakan 95% confidence level ni, 19 daripada 20 tu you akan dapat tepat. 1 daripada 20 tu you akan dapat salah. Okay, so this cara yang salah ni, okay, this is salah. Okay, when you interpret that the interval estimate just now means 95% probability that the population lies between, that is wrong. Okay, because it's not correct. The correct interpretation is this one. Okay, bahasa Inggeris ni dia makna dia tu lain sikit. So you have to follow it exactly. Okay, kalau bahasa Melayu pun try. I prefer bahasa Inggeris lah sebab nanti lain dia. Okay, so sekarang ni in exam, soalan tu tak adalah direct. Semua soalan tu tanya, okay, confidence interval estimation 94%, 91%. Kadang-kadang soalan tu, X bar tak ada. Okay, Z ni you can cari. Ni ada. You tak tahu N. So dia terbalikkan pula. Okay, you have, you tak tahu N ni. Tapi dia beri nilai standard error. Then you need to calculate this N value. So you kena tahulah macam mana nak adjust the formula tu supaya dapat. Okay. Any questions? Ada tak soalan? Okay. So kalau tengok kat portal ni. So this is the full slide. Okay. Mungkin dia ada lari sikit. Kalau tak you tengok di OpenCourseWare USM. This is the YouTube video. The one that is available at OpenCourseWare USM is the same that I put the link in this portal. The slide prezi for today. That will give you the overview. So by Monday, I will upload the second assignment question that will cover from normal distributions up to interval estimation. Any questions? I have 5 minutes. Ada soalan tak? Tak ada soalan. Anip, Shidi, Siong, Behestan. Ada soalan? Kalau siapa yang hantar, okay, make sure you use Razia_Adam at usm.my. Jangan guna razia.adam@gmail.com because my Gmail box dah penuh, okay. So make sure you always use razia_Adam at usm.my. Otherwise, feel free to share. You can ask questions kat ni, at our notice board, Padlet wall ni, okay, boleh guna di sini, okay, so janganlah segan-segan, okay, and then remember, okay, PB, yes, PB will be, why is moving, okay. PB will be until confirm, until today's topics, until chapter 10. Okay, yes, confirm. Okay, PB will be at chapter 10. So far, what I can tell you about PB, do we have another session before? Oh, we are done. Oh, okay. Thank you for that question. So basically for PB, you will have 20 multiple choice questions. Okay, 2 marks each, that will give you 40. And then you have calculation questions. That means one question, A, B, C, D, perhaps A, mean, B, median, okay, C, standard deviation, D, interpretations, okay, that kind of questions, okay, 20 marks each, okay, you need to answer 3 questions, okay, I'll give you more than 3, I think I'll give you 6 questions, you choose 3. There'll be also essay type question, maksudnya you don't like calculation because we already have cover data collection into all the different sampling method, you know, advantages, disadvantages of each, that kind of stuff, that it's possible for you to answer that, okay? But remember, the time is only 1.5 hours, so MCQ is 20 questions, 20 minutes, so we have 70 minutes. So the other 3 data structured questions, calculation, basically you have about 20 to 22 minutes for each question for you to score 20 marks. So 40 for MCQ and 60 for the other calculation and essay type. That will give you 100%, and it will contribute towards your overall assessment 20%. Okay? I hope that explains things. Summary data, what is the meaning of that summary data? I didn't get your question for PB. Summary data. Summary data? For PB, okay, basically it's manual calculation. You won't be asked to do, you know, like the exercise data yang guna Excel and that one is for your skill set. Itu kemahiran skill yang anda perlu bina, bukannya untuk tujuan exam. Untuk tujuan exam, yang manual calculation, calculate guna scientific calculator tu yang perlu digunakan. Okay? So, I don't actually understand. Formula. Formula is given, okay, the normal distribution table, student T, remember, kalau small sample, okay, small sample n less than 30, you cannot use normal. Okay, di andaian yang kita bincang hari ini, kita bincang normal, Gaussian semua tu, kalau sampel besar lebih pada 30. Kalau sampel kecil kurang atau sama dengan 30, you need use the student T, dia akan ada nilai lain pula, degree of freedom semua tu. Okay, so formula akan diberi, normal distribution table akan diberi, tapi I would prefer that you bukan memorize lah, you really understand the formula so that you can write on your own. Tak perlu tu. Because formula tu ada banyak-banyak bentuk. Standard deviation especially. Okay, formula tu ada banyak. Okay, so we have the shortcut formula as well. In terms of using the calculator. So I'll show you that during the intensive week. Okay, so that's all the time that we have today. Thank you for those who ask questions. Sebab dia ask privately, so I assume dia tak nak lah saya share nama dia. Okay, so yes, if Microsoft Office is not genuine, then certain add-in cannot be installed. That is correct. Okay, that is one way for Microsoft Windows, okay, for them to control their license. Okay, that's the catch. Okay, you cannot use that one. Okay, so you need to tompang lah kawan-kawan yang ada. Okay, kalau you tak buat, okay, you still boleh duduk peksa, no worry. Tapi nanti skill, bila you go for work or further study, skill, you dah belajar kuantitatif tapi tak tahu ke kira ni guna komputer. Malulah. Okay, saya yang malu bagi pihak anda. Okay? So that's all the time that we have for today. Thank you very much and I'll see you whenever I see you intensive week. Okay, assignment 2 by Monday insyaAllah. Okay, thank you and Assalamualaikum and salam sejahtera.